in this unit, what we've done is we've discussed the difference between ionic compounds and molecular compounds. We've discussed the difference in their characteristics. So ionic compounds are solids at room temperature, and the reason why is because of the strong attraction between the positively charged metal and the negatively charged nonmetal. And the positive and negative result from the transfer of electrons. Now, for molecular compounds, the way a covalent bond is formed is by the sharing of electrons. As a result, most molecular compounds aren't solids at room temperature, rather they are either liquids or gases. The other thing we've discussed is naming. Now, we've talked about naming ionic compounds. And just as a nice quick review, we've got two different types. We've got metals of known charge, and we've got metals of unknown charge. Now, why does this matter when we're writing the name of the ionic compounds? For metals of known charge, those metals include group 1, group 2, group 3, zinc, and silver. And the reason why it matters that we know their charge, that means that when we're writing the name of the ionic compound, we do not need to include the charge of the metal in the name. For metals of unknown charge, we do have to include the charge of the metal, and we do that by writing a Roman numeral behind the metal. And the reason why is because by just looking at the periodic table, you cannot tell the charge of a metal of unknown charge, and therefore we have to include it in the name. Now, that's for writing the name of ionic compounds. When we're writing the formula, all we did was cross the charges of the metal and the nonmetal, or the metal and the polyatomic ion specifically. And the reason why we did that is because we want the ionic compound to have no charge. Now, when we're talking about molecular compounds, we are not going to be crossing charges, and in fact, we won't know the formula based on just the name that's provided. So as a result, when you are talking about molecular compounds, you have to include the number of atoms in the name. And so the way that you do that is the following. You're going to provide prefixes. So you start with the first atom that shows up in the formula. You include a prefix to tell you the number of that specific atom, and then you put the name of the element. Then for the second atom, you provide a prefix for the number of that specific atom. You add the name of the second element to that, but you add an IDE ending. And this is the same thing as what we did when we were dealing with ionic compounds. Now, for prefixes, and these will be provided to you, if I have only one atom, the prefix is mono. If I have two of that atom, prefix is di, 3 is tri, 4 is tetra, just like tetrahedral, 5 is penta, like a pentagon, 6 is hexa, 7 is hepta, 8 of a specific atom is octa, 9 is nona, oops, that's an A, and 10 is deca. Now, there are two rules that you need to keep in mind when you're writing the name of a molecular compound. First rule, a molecular compound cannot start with mono. So MC, molecular compounds, cannot start with mono. So as an example, a molecule that you should be familiar with is CO. Now, based on these rules, the name of CO should be monocarbon monoxide. Now, it is not monocarbon monoxide because a molecular compound, the name can't start with mono. So instead, it is just carbon monoxide. So if you see an atom, if you see an element that starts without any prefix, it's assumed that there's only one of them. The second rule is that you can't have a repetition of vowels. this will make sense as we get more practice. It'll kind of come naturally. But for example, when I'm dealing with monoxide, I wouldn't write monoxide, right? Because that is a repetition of vowels. I've got two O's together. So instead, it would just be monoxide. I get rid of that O. All right? So I'm going to do the two example problems for you, and then I'm going to ask you to complete the next two practice problems. So number 1 and number 2 for this practice and the practice below it. So I'm going to start off. I've got 3 phosphoruses, so that would be triphosphorus. And then it is 4 fluorines. So 4 is tetra. And remember, for the fluorine, I've got to add the IDE ending. So instead of fluorine, it would be fluoride. Alright, so triphosphorus tetrafluoride. I need you to do number 1 and number 2. So pause the video. Okay. And then I'm going to have you do the next set of practice problems. I'm going to have you do number 1 and number 2. I'll do the example problem for you, though. So for nitrogen, because I only have one nitrogen, or sorry, I don't have a prefix, I assume that I have one nitrogen. And then for tri, that tells me I have 3 chlorines, so it's NCl3. So notice I'm not crossing charges. I literally just read through the name, and it tells me how much of each thing I need. I am not crossing charges here. For the next problem, I need you to do number 1 and number 2. Please note that this should be monocarbide and not just carbide, because that doesn't tell you how many there are. So do 1 and 2 as well, and that's it.